You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Good morning, everybody. My name is Bob Keane. I am the editor-in-chief of the internationally renowned journal Fire Ecology. Fire Ecology is a journal that is published by Springer and overseen by the Association for Fire Ecology, or AFI. I am the editor-in-chief, and today we're going to be talking in this Fire Ecology Chats about a very important paper that has recently been published. The title of the paper is High-Resolution Burn Prioritization Models Enhance Fire Management Decisions Heterogeneous Landscapes. And today we have the senior author that has come to talk to us, Andrea Nocentini. Andrea, can you introduce yourself?
Good morning, Bob. Thanks so much for inviting me to this podcast and for introducing me. I'm very happy to be here and be able to talk about the paper.
What is your affiliation, Andrea?
So at the time of the paper, I worked for Everglades National Park. I'm actually currently working for the Seminole Tribe of Florida, managing their water quality program.
Welcome aboard the Fire Ecology Chat train. I really appreciate you taking your time. Tell us about these burn prioritization models and how they enhance fire management.
Yes, so the paper that we wrote is novel in the way that it applies a known methodology, but to a large heterogeneous region, which is Everglades National Park. It represents the first attempt to optimize prescribed fire management in subtropical wetlands using a numerical model, which employs high-resolution spatial data, where until now fire management had been carried out mostly through expert opinion. You can imagine how hard it is to optimize fire management when you have a variety of conservation and protection goals within a heterogeneous 4,000 square kilometer region just by using expert opinion, but without adopting an objective framework. I believe expert opinion is still valuable, but should be supported by numerical models. The other important aspects of our paper is that it is the first to present a comprehensive overview of fire management in the Florida Everglades, accounting for all fire management objectives when attempting to prioritize and optimize prescribed fire use. Our paper provides an important perspective on the opportunities and challenges of managing fire in subtropical wetlands. For example, surface water expressions can be both an impediment and opportunity to achieve conservation goals. Let's think how it can support fire patchiness because of the microtopographical variations in ground elevation, but also how it can prevent achieving the planned fire extents because water, it's a barrier to fire in many cases, surface water. In the United States, fire research also is skewed towards Western ecosystems, and not enough people understand the distinct dynamics characterizing the Southeast and especially its fire-prone wetland ecosystems.
Great, that's a wonderful study. I really enjoyed reading the paper. So why did you do this study?
Sometimes these things come out randomly. So nobody had actually built a bar prioritization model for Everglades National Park before. And there was general interest in building one for optimizing prescribed fire decision making. We had talked about this with one of my dear mentors, Jed Redwine, when I was still a postdoctoral associate at Florida International University. And the opportunity became concrete once I started working for Everglades National Park. The model was built, and then I was able to collaborate on the paper with my other very important mentor and friend, John Kominowski.
So it took place in the Everglades. I've been there. I've been around a little bit. Where exactly did you do the study?
The study actually includes all of the extent of Everglades National Park. As I mentioned before, the whole extent of the park is about 4,000 square kilometers. The study specifically did not involve any field work. All the data used came from high-resolution spatial layers. We included all fire-prone vegetation communities, which are from drier to wetter, pine rocklands characterized by the Florida slash pine, marl prairies, and sawgrass-dominated marshes. We also accounted for wildlife whose habitats are dependent on vegetation structure and therefore are maintained by certain fire regimes. Above all, the Cape Sable seaside sparrow, the Florida leafwing and Bartram scrub hairstreak butterflies, and the Florida bonneted bat, which are also endangered species. Although no field work was involved, all co-authors have different degrees of knowledge on Everglades National Park, wetland ecology, and fire ecology. For example, Pablo Ruiz is the person who had generated vegetation maps for Everglades National Park in the years prior to producing the manuscript.
So I was reading your methods and I really got interested in them. Can you tell us a little more about them?
As I mentioned at the beginning of the interview, the modeling approach is not entirely novel. However, we have added to it a model evaluation process where we simulated fire management based on the priorities suggested by the model for 50 years into the future. This allowed us to calculate fire return intervals, the predicted fire return intervals, and to compare them with the target fire return intervals for the different ecosystem types and fire-dependent wildlife species. And these were the target fire return intervals were taken from the scientific literature. We have also included novel methods where we used simple statistics to generate a fire intensity potential index, a fire patchiness potential index, further supporting fire management decisions, especially in terms of fire seasonality. A heterogeneity index was calculated within burn units as well to identify subunits that could be targeted separately.
I think it's time for us to take a peek under the sheets and look at some of the results. If you can share just a little of the results with us.
Oh, yes, for sure. So the main result and what we found is that the use of our numerical models based on high resolution spatial information, we found that it could greatly support achievement of the conservation goals in large heterogeneous landscapes, while also protecting nearby urban areas and recreational and cultural values. But let's remember that also depends on resource availability. The additional results are the indices developed to further support achievement of the desired fire regimes, even at the subunit scale.
These results, are they important to management? What are the implications of the results to managers?
The method that we employed and expanded can be repeated in other heterogeneous landscapes or be adapted for other parts of South Florida with the additional removal of model criteria. Also, for the scientific community, I believe it is important to have the perspective of a different, partly understudied system in terms of fire ecology and management that in part defies the theoretical frameworks developed for the Western United States. Although fire ecology and fire dynamics have been studied in the Everglades, as I mentioned in the beginning, no attempts had been made to generate a comprehensive work on Everglades fire management. I look forward to other capable scientists to refine our analysis. I hope our paper can also help the scientific community focusing even more on the importance of fire regimes for Everglades restoration. As an important paper from my other good mentor and friend, Jay Sa, pointed out, the paper that I'm referring to is entitled Smoked on the Water, the interplay of fire and water flow on Everglades restoration. Hydrologic restoration of the Florida Everglades is pivotal, but sound management of fire regimes has to come along with it for restoration to be successful.
So I was looking at your author list. There's quite a list of people. You want to recognize any of these or funding agencies?
Yes, I'd like to recognize all the co-authors. The GIS experts of Everglades National Park, their names are Troy Mullins and Kari Alacorn, helped tremendously obtaining the spatial data, processing them, and supporting me when working with our GIS model builder. Similarly, Pablo Ruiz from Everglades National Park as well helped when processing the information because of his GIS skills, as well as his knowledge of the park and its vegetation communities. Both fire managers of Everglades National Park, Michael Gu and Maya Tupai, provided great insights on criteria selection and the fire management plan for Everglades National Park. The other co-authors, because of their expertise in fire ecology and or wetland ecology, provided a lot of insights during model parameterization and manuscript production. A shout out to John Kominowski, who found a title that was both captivating and reflective of the work, and who effectively reworked some of the manuscript sections during the final revisions.
Well, I surely appreciate you joining us. I want to thank you very much for your time today. Thank you, Andrea.
You're very welcome. And again, thank you for inviting me.
Yes, and those of you who are listening, if you are interested in this paper as I was, you can download it for free. For free, that's right, because Andrea and his crew have already paid for the cost of downloading the paper, and it is open source. So you can download it from our Fire Ecology website for free. The link, of course, is right on the podcast website, and learn all about this wonderful study. Until then, I'll see you at the next Fire Ecology Chats.
Thank you for listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology. If you enjoyed this episode, subscribe to our show and leave us a review. To learn more about fire ecology and support our future work by becoming a member, visit fireecology.org. FIREECOLOGY.org.